Welcome to the presentation Working with NeoPixels. I'm Altbeer and I'm going to walk you through this presentation. The presentation slide deck is available at altbeer.us/neopixels. So let's start off with asking the question, what is a NeoPixel? So NeoPixel is a term that was actually coined by ADAFRUIT to refer to their brand of individually addressable red, green, blue color pixels and strips that were all based on the WS2812 chip, and now they have other chips that make up their product line. These are integrated light source packages that use a single wire control protocol. Basically, they're little circuit boards, and so they have a single line to control the data passing through them that tells them what colors to light up. So the term NeoPixel is very popular, and it's become the de facto standard for addressable single wire LEDs, regardless of who makes them anymore. If you get someone that has a product out there that's not made by ADAFRUIT, chances are someone's going to call it a NeoPixel. So unlike a standard LED, even like the red, green, blue type, NeoPixels cannot be lit with just a simple circuit. You can't just apply power and ground and add a resistor and light it up the way you would an LED. They require a microcontroller to send control signals that will tell it how to light up. That is the protocol that allows it to light up multiple pixels in a strip, communicating to each one individually on the same wire. So that's what we'll go through. Let's talk about form factors. So NeoPixels come in many different form factors. From individual LEDs that have 4 pins like shown in the picture here, to surface mount NeoPixels that would have to be applied to a PCB, or to NeoPixel strips and rings and all kinds of form factors. So typically with the NeoPixels that are in strips and rings or in discrete LEDs, those are using the surface mount component and embedding them onto another product. So the NeoPixel strip, for example, it's a flexible strip that has a number of the NeoPixel LEDs on it, and the number of LEDs that's on it, it's measured in LEDs per meter. So you'll buy the strips in lengths of meters, and you'll see we have different values here, like 30 LEDs per meter might look like this picture, 60 LEDs per meter, which is the size and type that was provided in the Hardware Hacking Village lab kit. That is what this one looks like, and you can get much denser LEDs per meter. This picture shows 74, but I've seen as dense as 144 LEDs per meter. So they come in a lot of different form factors, and that's what makes them very popular for use in projects, because it's very easy to control a large number of LEDs without having to connect to every LED's pin individually with a controller. So let's talk about some of ADAFRUIT's NeoPixel resources. So ADAFRUIT's website is adafruit.com. They carry a wide range of NeoPixel products on their site, as well as microcontrollers that would control them. They also have some devices that contain both the microcontroller and NeoPixels and other cool things all in a single form factor. So it's a cool site to check out if you haven't seen it. There's a lot of good products there that are great for people wanting to play with hardware in different ways. ADAFRUIT also put together an awesome NeoPixel guide. They call it their Uber guide. You can get to it by searching on the ADAFRUIT site, or via this link below. It's kind of a long link, so I suggest you just Google NeoPixel Uber Guide, and this will probably be the first thing that pops up. So let's talk about the libraries. So working with NeoPixels means that we have to send it a control signal, and we have to adjust for the different NeoPixel chip hardware, because there are slight differences based on the chips. Like the WS2812 chip might work a little bit differently than the APA 106 chipset, and so those are differences that have to be managed. And the way that we work with the NeoPixels in our code is to usually load a library. Now we can write that library on our own and write the code to actually interface and talk with the NeoPixels and tell them which pixel is going to light up which color and how. Or we can use libraries that have already been created for this purpose, which is what I usually do. So ADAFRUIT has created a couple of libraries, one that works with the Arduino code base, so the Arduino scripting language, and another one that works with CircuitPython. So the Arduino library is called ADAFRUIT _ NeoPixel, with caps as shown here. And it can be installed via the library manager in the Arduino IDE. So if you're using the Arduino IDE, open up library manager and you can just search on NeoPixel and you'll see several options, one of which is the ADAFRUIT _ NeoPixel library. So you would install that from there. If you're not working with the the Arduino IDE, you could also download it directly. It's available on the Adafruit website, so you can download that library and work with it directly in whatever IDE or editor you're using to push code to your Arduino. But once you have that library, you're just going to include it in your code, in your Arduino code. And then the CircuitPython library is named NeoPixel.mpy. It's all lowercase. It's a compiled Python file, and this is available as part of the CircuitPython library bundles. So on the CircuitPython site, you'll see a place to download library bundles. So CircuitPython comes with a bunch of libraries that are embedded, but anything beyond that, you have to download separate library files and then use those on your Trinket or whatever other device that is running CircuitPython. So once you have that library file downloaded and you install it into the lib directory on your device, you're just going to import the NeoPixel library in your code using the Python import. So let's talk about how we connect NeoPixels. So to connect NeoPixels, you must provide power to them, usually 5 volts. And then you also have to connect it to ground. And then you have a control wire. This is the single wire that we were talking about. That control wire is going to send the signals to the NeoPixels to tell them what to light up and which one is going to light up what colors. So that control wire would usually be connected to the data in on a NeoPixel chain. So the picture on the right shows a NeoPixel strip, and what you would do is on the bottom here, you would connect up 5 volt and ground and data in. You wouldn't have to connect anything up on the other side, because the 5 volt and the ground are acting like power rails. They're just running these lines completely down the strip. And then each data in is connected to a data out on the other side. So you can see where the data in is going to data out. And so as you're chaining through the pixels, the data in and the data out are chained together. So we only really need to connect to one wire. And then on each pixel, they terminate that to ground as needed. So you don't have to worry about that. So this allows us to just worry about 3 major connections: a voltage in, which is 5 volts here, a ground, and a data in. and then the data outs will be chained on the strip. Now, if you were connecting discrete components like physical LEDs or working with these SMD chips, then you would have to worry about doing that chaining of a data out from one pixel to the data in on the next on your own. So while a small number of pixels can be powered by a single microcontroller's output, that's not recommended for large strips. Large strips can quickly exceed a microcontroller's power limits. So for example, each pixel with all colors lit can draw a maximum of 60 milliamps of power. Microcontrollers have limits onto how much power they can provide on their power pins. Some are at 500 milliamps, some are at 250 milliamps. It just depends on the microcontroller. But you can see with limits of like 250 or 500 how pixel max draws of 60 would quickly limit the number of pixels that you can safely power off a single power wire of a microcontroller. So typically you would wire the power to an external power source, not the microcontroller power source. In our examples, though, where we're going to be working with a very limited number of strips, we will be connecting directly to the microcontroller power. But it's important to note that you typically wouldn't do that. You connect to an external power source for driving a large number of pixels, or even a small number greater than maybe 5 or 6. And then also we need to worry about noise on the line and current onrush. And so what we're going to do is put a large capacitor between the power and the ground. Usually for a large strip of pixels, we're looking at a 1,000 microfarad capacitor. And what that's going to do is prevent, when we first power on the NeoPixels, we want to prevent that initial onrush of current draw to provide a voltage drop, because that current draw is too much. So by having a large capacitor in there, it smooths that out so that the voltage doesn't drop if when we first powered on and there's that large onrush current. So the other thing that we need to worry about is noise on the control line. So the control data line should contain a resistor, usually between 300 and 500 ohms. I've always used 470 ohm resistors for this. And that's going to go in between the microcontroller and the data in line on the NeoPixel. So the microcontroller line going to the NeoPixel might need this resistor here just to keep that data line clean and prevent spikes of data, spikes of voltage rather, on the data line that might damage the pixels. Like when you first power on the microcontroller, there might be a spike of voltage on that line. So we're just trying to keep that line clean. That way the NeoPixels don't get damaged. So let's talk about NeoPixel addresses. NeoPixels are individually addressable. What this means is that you can identify each individual pixel in a chain to control it, even though they're all using the same control pin. They're not all on different pins. So if you've worked with other LEDs on microcontrollers, you know that usually you have each LED on its own control pin, like data 1, data 2, data 3, and you'll turn those data pins on and off as you want to turn the lights on the LED on and off on each one. That's how you would individually address them. Well, here I'm only going to have one pin on the microcontroller. Let's say it's data 1 or whatever. That one pin is going to control a whole strip of NeoPixels. So how do I identify them? Well, in the way the NeoPixels work in the library code, they're identified similar to the way an array would work. So when you assign an object as a NeoPixel object in your code, you can then identify individual pixels from that object. How that works is slightly different between Arduino and CircuitPython, but in both references it's similar to addressing elements of an array. If you think about the NeoPixel object as an array, we're addressing elements of that array to talk to the different individual pixels. So let's talk about how we specifically work with these NeoPixels in code. We're going to start with the Arduino code. So in order to work with NeoPixels on Arduino, you need to do the following. You're going to include the library. That's the first thing. And in Arduino, that's a hashtag include or pound include, and then the NeoPixel library. Then we're going to define an object to reference the NeoPixels, and it uses the following syntax. We're going to say ADAFRUIT NeoPixel. So this is our object type. So instead of integer or some other type, we're using ADAFRUIT NeoPixel as the type. Object here is our object name, so we can name it using the same type of rules that you'd use for variable naming. And then you're going to say it's equal to ADAFRUIT NeoPixel and then the following inside a parens. We're going to first give it this list with a number of pixels. So this is where we tell it how many pixels are in our strip of pixels. We're going to tell it which pin on the microcontroller is controlling the control line for that pixels. And then we're going to add type flags. So we're going to do type flag plus for as many type flags as we want to add. The type flags are identifying what type of NeoPixel it is. So there's several different hardware types of NeoPixels that work a little bit differently. Some of the major ones that we want to identify here are whether the NeoPixel is wired up as a green, red, blue, or as a red, green, blue, or there may be some other variations there like red, green, blue, white. So based on the pinout of the NeoPixel, we have to identify that, and we do that with a type flag. And then the other thing that's important to note here is the bit stream rate. So we have to tell it whether it's running at 800 kilohertz or 400 kilohertz. So depending upon the pixel, it might use a different bit rate. And we do that with this code here. So an example is this line in green where I have my ADAFRUIT NeoPixel. I'm naming the object strip. And then I'm telling it that strip has 5 pixels on it. It's running on pin A1 on the Arduino. And it's a green, red, blue. So that's the Neo_GRB plus Neo_KHZ800. So it's an 800 megahertz pixel. Once we have that object set up, within the void setup part of the Arduino code, we want to prime this object by doing a strip begin and then a strip show. And what this does is it just gets the NeoPixel object ready for use, and it blanks it out to where it's not showing any color initially. Then within our main loop, we're going to assign the NeoPixel colors using the following syntax. So it's going to be the object name dot set pixel color, and then this list of information that's going to include which pixel number we want to affect with this code. Then the red value, which is going to be a number between 0 and 255, 255 being fully on and 0 being fully off for red. And then the same thing for green and then for blue. So when we look at an example here, let's say we want to set the third pixel in my strip object to be bright red, I would use this green code here, strip.setPixelColor, and then I'm using number 2 here because the NeoPixels are numbered starting at 0. So the third pixel would be the number 2 because we're going to have 0, then 1, then 2. And then 255 for red, and I zero out green and blue. So that will light it up red. So then after I assign the colors, I'm going to use the object show to send that assignment to the NeoPixel, because all I've done here is assign it to this variable, and now I'm going to send that data to the NeoPixel with the show command. And so in my example, that would be strip.show. So beyond that, you would work with NeoPixels the same way you would any other LED inside your code. You can add delays to showing the colors, you can put them in loops, you can do whatever else you need to do, and it works just like an LED. But those are the key points on an Arduino. So next we're going to look at how we work with NeoPixels using CircuitPython. So if you're using the Trinket or one of the other ADAFRUIT microcontrollers that supports CircuitPython, here's how you would work with NeoPixels. So first you're going to import the library with import NeoPixel. Next you're going, and I should say this assumes that you already downloaded that library and put it in the lib directory on your device. And we'll go into that a little later. So next we're going to define the object that we're going to use for the NeoPixels. So we're going to give it object, which is our object name, is equal to NeoPixel.NeoPixel. And basically it's the second NeoPixel is a function within the NeoPixel library. That's why it's worded that way. And then we're going to give it a number of parameters. The first one is the pin number. So this is the actual physical pin on the microcontroller that we're using to control the data line for this NeoPixel strip. The next is how many pixels, the number of pixels that are in this chain. And then the next values are flags. These flags set up the type. So this is how we determine what type of NeoPixel we're working with and other information that we want to pass to the NeoPixel as part of this object. And so that is typically flag equals and then the flag value, and you comma separate as many as you need to add. So some typical flags that are set are the pixel order. So this is where we'll tell it whether it's a green, red, blue or red, green, blue. And we do that with a value of neopixel.grb or neopixel.rgb. And there are other values we get set for that as well. Then we have auto write. So auto write is a feature as part of this NeoPixel library that defaults to true. So we don't have to set auto write if we want it to be true. But what this does is when we set a color for a pixel, it's automatically going to send that information to the NeoPixel. We don't have to use a show command to send that data. Now you can set this to false if that's not the behavior you want. If you actually want to wait until you've set all the colors to do a single show to send them all out. And then we have a brightness that can be a value from 0 to 1 and any decimal in between there. This is the percentage of brightness that the NeoPixels are going to be set at. Some of these pixels can be extremely bright, and so we might want to dim them down a bit with this. So an example is this green line here, where I'm calling my object strip, and I'm setting it to pin D1 on the board. I'm telling it has 5 pixels in this strip. And then the pixel order is NeoPixel green, red, blue. And then my brightness, I'm setting it to 70%. And because I didn't specify auto write, that would mean it would be defaulted to true. Now we can also adjust or set the flags, the type flags of a NeoPixel object outside of its initial definition. And we can do that by specifying our object name .flag equals flag value. So let's say I had defined this object and then I decided, well, for this part of the code, I don't want auto write to be true. So I'm going to, using my example of strip, I'm going to say strip.auto_write equals false. And that's going to change the value, the type value of auto write from true to false. And then within our main loop, to assign the NeoPixels colors, we're going to use the following syntax. So it's going to be object pixel with pixel in square brackets. So it's going to look similar to how you're referencing an array. And then equals, and then we're going to give it a list, which is in parens, which is our red value, which is going to be between 0 and 255, our green value, and our blue value. And I should note that this syntax is the same. Red, green, and blue is the list that we're giving it, regardless of if the pixel is a GRB or an RGB. It's going to figure that out, which is why we define that as a type flag. So we're always going to give it the list in red, green, blue order. So as an example, if we wanted to set the third pixel in our strip to bright red, we would say strip and then our square brackets around 2, and then equals, and then in parens 255, 0, 0. So now after assigning the colors, if auto write had been true, we wouldn't need to do anything else. It would just show those colors. But if auto write is false, what we're going to have to do is use the object.show function to send that information to the NeoPixels. So in our example, that's going to be strip.show. Beyond that, you're going to work with NeoPixels the same way you would any other LED in your code. So you can add in delays with like a time sleep. You can put them in loops. You can do anything else you need to do, but this is how you reference the NeoPixel LEDs. All right, let's take a look at our upcoming NeoPixel projects. Okay, so in the next section of the presentation, we're going to outline some projects using both the Arduino and the ADAFRUIT Trinket. These projects are going to be centered around two different physical circuit layouts or similar circuit layouts using the two different types of microcontrollers. And then we're going to run through three different code examples for each. So the first three are going to be focused around the Arduino code, and the next three are going to be focused around the CircuitPython code. So the first thing we'll do in each case is we're going to blink a single NeoPixel. Then we're going to blink a strip of NeoPixels, and then we're going to color cycle a strip of NeoPixels. Now, the lab references that are here, 6 and 7, these refer to the BSidesDFW hardware hacking village and the specific hands-on lab videos associated with that. So you can access links to those videos, which will go into much more detail and have actual hands-on information on how to build these circuits and work with the code. Those are listed here on the link below. All right, so let's talk about our first circuit. So in this circuit, we have an Arduino Nano pictured in the center of the schematic. And what we have is off to the right here, the bottom right, we have a single discrete LED-sized NeoPixel. It's an 8mm LED-looking NeoPixel. And this shows how we're going to wire it in. And then on the left side, we have a strip that has 3 NeoPixels on it. And this will show how we wire it in. And then we have our power and ground. So let's start with the power. So we have a 5-volt power coming off of this pin on the Arduino Nano. And I'm just tagging it here with a plus 5-volt tag, which means it's also connected to anything else with a 5-volt tag. So that means that is going to be wired into this single NeoPixel on its a voltage in pin, and it's going to be wired into the strip on its 5-volt voltage pin. And then we have our ground line coming off the Nano. And I'm just tagging it here as GND, a label that shows that it's connected over here to this NeoPixel on its ground pin, and it's connected to the strip on its ground rail. Now, in between the 5-volt and the ground, I have a capacitor there. So this capacitor for our example, we're going to be using a 220 microfarad capacitor. So it's not as high as the 1000 that we talked about before, but we're only dealing with 4 pixels here. So a 220 UF capacitor was deemed to be enough for that. And then for the data lines, I have A1 is going to be feeding this single pixel using a 470 ohm resistor. And then I have D10 is going to be feeding the data in on the strip using a 470 ohm resistor. And so with this, I should be able to create objects on either of those data pins as NeoPixels, and it should work fine. Now, one thing I noted here is just an optional, is that you could hook up a battery to the voltage in on the Arduino Nano. A 9-volt battery would power this and all of this circuit. For our lab work, we're going to be connecting in primarily with the USB connector on the Nano. All right, so this is the Hardware Hacking Village lab strip board that we've been working on with the 5 previous labs. So it will have all of the components from all 5 of those previous labs, and we're just going to add to that. So what we're adding, there's a whole lot of wires in this and not that many components. So we're going to be adding the 2 470 ohm resistors we talked about, a capacitor that's 220 microfarad. We're going to add an 8 millimeter through-hole type NeoPixel. And then we're going to add a strip with 3 NeoPixels on it, a traditional strip. So you can see here on the diagram, we have our 8 millimeter LED here. We have our strip here. And the way that we're wiring this in with the strip is we're going to solder the points of the strip to the actual through-hole connectors that are on the strip board, so that it's part of these strips, and we can connect other wires to those, and it will connect in here. It's a little tricky to get solder to stick in that type of place, but if you can make that work, that works great. And then we use another wire here, not for any kind of electrical connectivity, but as a holder to make sure we're holding that strip straight. That's important because if with these solder points here, if something were to pull on this strip, it might break the solder points away. So when you're building this circuit, that's an important note to secure your strip. So as we can see from this diagram, we have our capacitor here is in between the power and the common rails. Now, unlike the previous labs, we are connecting in the Arduino part into this common negative rail on the strip board. And that'll be important because we have a lot more connections going to ground than the Arduino pin alone would support. So without going into great detail here, you can see exactly where on the strip board you connect. And then in the actual lab video, we'll go into details on how to put this circuit together. So now let's get into the code. So our first piece of Arduino code is just going to blink that single 8 millimeter NeoPixel. So the way we're going to do that is we're going to do our hashtag include to include the library. And then we're going to define, we're going to call it LED6 because that was what the LED number was on our schematic. So the LED6 pin and the LED6 number, I'm just defining those as constants here. So we have A1 and we have 1 pixel. So now when I create my object, I'm creating the object and I'm calling it LED6. And I'm giving it the LED6 number as the number of pixels. Then I'm giving it what pin it's running on. This particular pixel is a red, green, blue layout running at 800 kilohertz. So I put those values in here. Then in my void setup, I'm going to do LED6.begin and LED6 show to prime that NeoPixel, get it ready for use. And then in my main loop, the first thing I'm going to do is set LED6's pixel color to red. And you'll notice I'm calling out pixel 0 because I only have 1 pixel on this string. And then I'm going to put a delay in there. I'm going to do a show, and then I put a delay of half a second to show that red color for half a second. And then I'm going to do the same thing to set it to green and then to blue. And it'll keep cycling through red, green, blue, with a half a second delay in between. So the code is not that complex. The most important thing is getting the object definition correct. So the next piece of code expands on the previous one in that we're going to add in that external strip of 3 NeoPixels. And we're going to make each of them show red, green, and blue. So the definitions for those are going to be for LED 7, we're setting it on pin 10 and telling it there's 3 pixels in the chain. And we're going to set our object for LED 7. Now in this case, the strip is using green, red, blue. Now most of the strips that I've ever dealt with are always green, red, blue. Some of the newer ones add white in there, but the typical layout is GRB and 800 kilohertz. And then we're going to add that to the setup to prime LED 7. And then we just add some lines of code to light up pixels 0, 1, and 2 on that strip as red, green, and then blue. And then on the next one, we're going to do the same thing, 0, 1, and 2, but now we're going to shift which ones are red, green, and blue. And we do the same thing with the next group. We're going to show each one for half a second, so it's going to cycle through red, green, and blue on these pixels. And our last piece of Arduino code is a color cycle. So this uses all of the same code from the previous example. The only difference is what we're doing in the main loop. So I cut out the rest of that code to show you the main loop. And for this, I'm using a for loop to run through 0 to 255. And then setting that as a position. And then based on the position number, I'm going to set the red, green, and blue values, starting with red and green, then red and blue, and then green and blue. And this just gives us a nice color wheel of changing values. Now, because this is running through 255 different color iterations, we want to reduce our delay. So I made it 50 milliseconds instead of the 500 or half a second we had before. So this will be a lot quicker moving through this loop, but it's going to produce a nice looking display. And it just shows how you can do different things with math or with loops using these LEDs the same way you would any other LED. All right, now let's talk about the Trinket layout with NeoPixels that we're going to use CircuitPython to control. So I have my Trinket defined here, and I have ground called out to a label. I have 5-volt output called out to a label. And then I also have the same exact NeoPixels that were in the previous example. So we're reusing this hardware in our circuit, but for the diagram, this is what it's going to look like. So I'm going to use pin D1 to drive the data in on the single 8mm pixel with a 470 ohm resistor. And I'm going to use D0 to drive the data on the strip of 3 pixels. I have a capacitor here, the same capacitor I used in the previous example, a 220 microfarad capacitor between ground and 5-volt. And then optionally, I could hook up a battery to the circuit. In this case, I would need to use 3 AAA batteries providing 4.5 volts of power. And I would wire it to this 5-volt rail. Now you'll notice the Trinket has a battery input. That battery input will not put power out of this 5-volt because this is both an input and an output for USB power. So what we're doing is wiring our battery into 5-volt because that is where we're wiring all of these pixels to. So this will allow the battery to drive the power of the pixels outside of the Trinket, but then because this is also an input for power, it will also power up the Trinket. So that's why we chose that particular connection for this battery if we choose to deploy it. And so here we're looking at what we need to build on top of what we already built in the previous lab. And there's really not much. We're going to add 3 wires and a resistor. So the 3 wires that we're adding are first for power. So we're adding a power wire from that 5 volt, and we're bringing it around here to where the strip is. Now, because that strip is also wired into power here and the capacitor and power there, it's acting as a power rail. And so that gives us access to the capacitor. It also gives us access to powering both NeoPixels. So that power line right there is the first wire that you would run. The second wire is going to go to a 470 ohm resistor. This is the one component we're adding at this point. And we're adding that resistor into, I forget which pin this is, D0, D1. I think that's D0. And then we're going to run a yellow wire from that resistor over to the LED strip here. Now the next wire that we're going to deal with is on D1. And I'm not using a resistor here. And the reason why is we used D1 in one of the previous labs and wired up this bare wire here that's kind of in our way. We wouldn't have room to put a resistor in here. And honestly, we didn't need to put a resistor in there because we can use the same 470 ohm resistor that we did in the Arduino lab previously. So all I'm doing is wiring a white wire here from the D1 strip. I'm driving it through over to where the 8mm LED is, and I'm hooking it. It's kind of hard to see here, but it's going underneath that resistor just because of the way the resistor was placed. But it's on the same rail. It's on the same strip as that resistor. So this is the same place the Arduino pin would plug in if it was on there. So what this does is it allows us to complete the circuit with the wire going to the resistor, which then goes to the LED. So it's still showing the same circuit that we have here, where we have this resistor before we get to the strip and we have a resistor before we get to the LED. The only difference is we're reusing the same resistor that we had from the previous lab. So with those connections in place, then we're ready to write some code. Now, I mentioned this before, but this gives you some details on the CircuitPython library files. So in order to work with NeoPixels, we need to have the NeoPixel MPY library file added. And it needs to be the one that corresponds with the version of CircuitPython that we're working with. So in these labs, we've been working with version 5. So you would download the bundle for version 5. You'd find this file in that bundle on your PC, and you would copy it to the CircuitPy directory under the lib directory on the CircuitPy drive. You can get the library bundles from circuitpython.org/libraries. Now, once that's done, we can write some code. So this piece of code is going to blink the single 8mm LED. We're going to import our NeoPixel library. And then we're going to define some information. So I define some constants here as LED pin, LED6 pin, LED6 order. And this defines my pin of D1 and my order is RGB. And then we're going to create the NeoPixel object. So my LED6 equals NeoPixel that is set to the LED6 pin. I put the number 1 here because this is the number of pixels. So this has 1 pixel in the string. Then my pixel order is equal to LED6 order. And in this case, I'm setting auto write equals false. And then I'm going to run through the main loop where LED6 0, so that's the first LED in the strip, which we only have 1, is equal to 25500. So this is red. Then I'm going to show it. And then I'm going to go to sleep. And that sleep is how we delay. So I'm sleeping for half a second, and then I go through and LED6, I just set it to off. So all of them are 0 values. I show it and I sleep. So this is just going to blink that LED red on and off. So our next piece of code is where we're going to blink the strip. So here we're defining the LED 7 pin as D0. We're giving the order as the green, red, blue type of order for the pixels. We define our strip our strip NeoPixel object using that pin and that pixel order and telling it that there's 3 pixels in the strip. And auto writes false again. In this case, this strip is very bright, so I want to turn down the brightness. So here's where I could have set it in the definition, but to show you how that would be done outside of the object definition, I'm setting LED7.brightness equals 0.3. This sets it to 30% of its normal brightness. Then I'm going to go through my main loop, and in my main loop, I'm going to set the first pixel in that strip to red, the second pixel to green, and the third pixel to blue. And I'm still setting my 8mm LED here as a red LED here. I'm going to show for both of these. I'm going to sleep for half a second, and then I'm going to turn them all off and sleep for half a second. So it's going to blink these colors on and off. Okay, whoops. So the last piece of code before we end is color cycling the NeoPixels. So with this code, we're defining them in the same way, but I'm defining a function called wheel, and we've used this function in the CircuitPython class, so you may be familiar with this. And this is also a function that's included in the demo code on the Trinket. So this just takes an integer from 0 to 255, and it will use that to create a list of red, green, blue colors as a return value. And using that, I decided to blank out the 8mm LED for this one. And then for the strip LED 7, I'm setting all 3 pixels, 0, 1, and 2, to that function. And then going through this loop, setting the value of I that's used in that function to a value between 0 and 255. And it will send that and change the color. And then my time sleep, you'll notice, is much smaller so that it goes through this loop very quickly. And that's all there really is to it. The code is available here on my GitHub. And the NeoPixels slide deck that I just went through is available under altbeer.us/NeoPixel. So I hope you enjoyed this presentation, and I hope you learned something from it. And if you're interested in building out those circuits and working hands-on with making that code work, then I encourage you to look at the lab videos associated with this class. Thank you so much.